Hello everyone, my name is Palak Donga and my ID is 24CS020. Today I will be presenting my case study titled Solar Storage Warning System. This project was created with a clear purpose to make home solar systems safer, smarter and more user friendly. Let's begin with a brief abstract of the project. In today's world, solar energy is becoming more popular because it is renewable and environment friendly. Many homes and businesses are now using solar panels with battery storage systems. But often, users don't realize when the battery level is too low, and this can cause problems, even damage to the battery. So, I designed a solar storage warning system. This system tells users how much power is stored in the battery and gives a warning sound when the power drops too low. This way, the user is always aware their system status and the battery lasts longer. Introduction: Solar storage systems. A solar storage system stores energy during the day and allows you to use it when there is no sunlight, for example, at night or during a power outage. These systems are very useful, but they need monitoring. Just like our phone batteries, solar batteries are also lose charge and get damaged if overused or completely drained. That's where a battery level indicator is helpful. Introduction to battery level indicator. The battery level indicator shows how much charge is left in the battery. In our system, we use 10 LEDs to show the charge level in steps of 10%. So if 5 LEDs are on, it means the battery is at 50%. This is a simple and clear way to monitor the power. No need to open apps or check meters. We also added a buzzer that alerts the user when the battery level is critically low, such as at 30% or below. The main objectives of these projects are to build a working system that gives real-time battery feedback, to use basic digital electronics and logic circuits, to make a simulation of the project using DIT software, and to improve the idea by combining both visual LEDs and audio buzzer alerts. Methodology. Let me explain the working of the circuit. We use the LM3914 IC, which can drive 10 LEDs based on analog voltage input. This IC helps us to show the battery percentage with LEDs. For the warning part, we used a 7404 NOT gate IC to create a logic control that activates a buzzer when certain LEDs are off, like those representing 60% and 90%, it means the charge is low. That condition triggers the buzzer. We also use basic components like resistor, a variable resistor, and a push button to test or trigger the circuit manually. Methodology: software simulation. We use the DIT software to simulate the circuit. In the software, we drew the circuit, connected the LEDs, and applied the logic gates for the buzzer. This allowed us to test the visualize the working without physically building it at first. Simulation helps us understand the timing, voltage levels, and logical conditions clearly. These are the components and its quantity which are used. We Draw three truth tables: first lamp, second buzzer, third combination of lamp and buzzer. In this system, we use three key inputs from the LM3914's outputs. A is equal to 30%, B is equal to 60%, and C is equal to 90%. These outputs are connected to the logic gates. We created a truth table to understand the buzzer's behavior. For example, if A, B, C are all low, it means the battery is under 30%, so the buzzer should turn on. This logic ensures that the buzzer only rings when truly necessary. From the truth table, we formed a logical equation: A dash B dash C dash or A B dash C dash. This means the buzzer turns on in two conditions. First, when battery is critically low, all inputs are low. Second, when a certain low charge combination happens. This equation was simplified to make the circuit more efficient. Logic circuit of solar storage warning system. Simplify equation. In this project, we simplify equation using two methods. First, Boolean theorem. Second, K-map. Using Boolean theorem, A dash B dash C dash or A B dash C dash becomes B dash C dash after simplification. Using K-map. This is a visual method that shows the same result, B dash C dash. By simplifying the logic, we reduce the number of gates needed, which makes the circuit more efficient and easier to build. Logic circuit design. Here is the final logic circuit diagram. The LEDs are driven by LM3914 and the logic gates take output from it. When the battery level is low, the logic circuit activates the buzzer. The push button S2 can be used for testing. All the components work together to monitor and alert the user. Advantages of the project. This project has many advantages. It extends the life of the solar battery by preventing deep discharge. It provides early warning, which helps user take an action. It is a low-cost system using simple components. It helps in troubleshooting during maintenance. And most importantly, it gives users peace of mind. Disadvantages of this project. Like any project, there are some limitations too. The design is still basic and not waterproof. The system is not connected to the internet, so it cannot send remote alerts. And finally, the design can be improved to look more professional or compact. In summary, this project is a working solar storage monitoring system with a visual indicator and a buzzer alert. It uses digital electronics in a smart way, combining analog input, battery voltage, and the digital output, LEDs and buzzer. The system is easy to use and can be further improved for real-world applications. As a conclusion, this project has successfully achieved the desired objectives and successfully implemented in a given period. It is hoped that this system is accepted and will be used, and the results obtained from this research can meet the needs of all the users. Finally, we hope this product can be fully utilized and can be commercialized in the market in the improvement of battery level indicator products to a higher level. Thank you.